Today we're talking about what is the best sub-base for resin-bound surfacing, and this one has got a lot of subjectivity within the industry. MOT Type 1 hardcore versus Type 3, ground reinforcement grids versus just doing an overlay. We've seen and heard it all before, but some base preparation systems can become huge problems for both installers and their customers. So let me address what we believe here at Rhino Surfaces is the best 5-part base building process which we've developed over the last 16 years of installation experience. If you think overlaying a resin-bound surface onto an existing one is a good idea, well, let me be blunt with you, it's not. There are a number of different reasons why this is the case, but let me just share a couple of the obvious ones. The first one being its structural integrity. If the underlying surface is compromised, and what I mean by that is it's cracked, uneven, or perhaps deformed in some way, and the chances are it probably might be already, and that's partially the reason why our customers perhaps brought you in to install them a new surface. Now, if this is the condition of the surface that you're laying on top of, it will without doubt affect the durability and the longevity of the resin-bound surface that you're about to install. These imperfections could be visible straight after the install has taken place, and if they're not, they may become visible over time, even resulting in some cracking or even sunken areas. The second reason why it's not a good idea to overlay is because there will be movement in the substrate. Any underlying surface is always subject to movement, especially to changes in temperatures and weather conditions, and especially when it's more of a sudden change to either of those things. Why slabs, block paving, and even tarmac can become uneven or sink over time. And that's because the soil that's underneath it is going to be contracting and swelling during different weather conditions. Now you've got to think, if that's the structural support for the resin-bound base on top, then any deformities underneath will affect that resin-bound surface. So this is where we begin any install, by doing a full dig out of the existing surface. It doesn't matter what the surface is, tarmac, blocks, slabs, we pull the thing up, usually taking it down to between 200 and 300 mil, depending on the ground conditions. Fundamentally, the reason why we do this is not only to just make sure our customers are happy with the quality of the end product that we're providing them with, but also to reduce our own risk and liability too. And you'll see a lot of this thought process in our approach to preparing a surface throughout the course of this video. Next up, we lay a geotextile membrane, but you may wonder, well, what exactly is the point in that? Well, the membrane creates a layer of separation between the soil and the hardcore, which we'll get onto in a couple of steps' time. Essentially, it prevents any of the fine particles from the soil migrating into the hardcore, and this helps maintain the structural integrity of a surface over time. Also, from preventing the mixing of hardcore and the soil, it ensures the hardcore remains stable and evenly compacted, reducing the risk of subsidence. Next up, we installed the ground reinforcement grid. Now, installing a ground reinforcement grid is actually written into the highway spec. The CD225 revision 1 document recommends the use of geogrids and or a geotextile membrane on less stable ground rather than excavating to depths of 500 to 1000 mil. We consider the use of both as best practice to give maximum stability on any surface. So if that's the standard, which has no doubt been approved by committees of structural engineers, then that's the standard that we want to be following here at Rhino Surfaces. But next up is a controversial one, and one that's got a little bit of subjectivity within the industry. Now, it's the strength versus drainage dilemma that makes this one so subjective within the resin-bound industry. So let's talk about why we have a preference towards using Type 1 hardcore over Type 3. Type 1, once compacted in 100mm layers, results in a highly stable surface, and it is also the preferential base which is used in the construction of roads and motorways, so it has an extremely high load-bearing capacity. Now, when we think about load-bearing capacity and the ever-growing demands of weight on our driveways, this is why we use Type 1 over the Type 3. Now, as we move more and more towards electric vehicles, this becomes ever more important. To give an example, the Peugeot E208 is double the weight of the internal combustion engine equivalent Peugeot 208 at 2 tons. You make that a 2-car driveway, and all of a sudden you've now got 4 ton of car weight sat on the drive instead of 2 tons. And that's admittedly comparing a relatively small vehicle. Now, when you combine that onto the fact that we're laying on top of a substrate fundamentally that will move over time ever so slightly, we believe that we should be prioritizing strength and stability all day long. Now, because Type 3 has less fines in it, it's actually a weaker surface, roughly about 20% weaker in fact than Type 1. But having said that, it is still okay to use in driveway specifications. The only real benefit that we see of Type 3 over Type 1 is that it's slightly more permeable. So it would be better aligned to a project that required better drainage characteristics like perhaps more extreme weather in tropical climates, or even in places that are at a higher risk of flooding. Having said that, type 1 is still porous, it just won't drain the water quite as fast as type 3. But if the strength argument isn't enough, I'll explain why the permeability argument is not as important in our next step, because the base build process doesn't stop at the hardcore. The final part is a rubber crumb base. It's a mix of recycled rubber tyres and granite stone. And because it's made predominantly of rubber, it has flexible characteristics that both type 1 and type 3 can't offer. This allows a sub-base which is built with strength and stability at the forefront of our mind, the ability to move and flex slightly without cracking the top surface. Now we layer this fully permeable, SUDS compliant system at a 40mm depth. This allows for effective water management, reducing the risk of puddles, waterlogging, or freeze thaw. Now when you consider you've got an additional 20mm of resin bound surface on top of a 40mm permeable surface, you're talking a 60mm surface that will allow water to drain straight through it at a rapid rate of knots. In actual fact, it will drain water at the equivalent of 25 litres per square metre per second. Hence why we opt for a stronger type 1 hardcore as opposed to a more permeable type 3. And funnily enough, by using this system, we've never ever had a customer call up in the past 16 years to say that they've ever found a puddle on their driveway. So we certainly believe that this is a base build process that works. Now preparing your base is only one part of the full installation process. So if you would like a more in-depth video of how we actually install a surface from start to finish, then be sure to check out this video here. Be sure to subscribe to the channel as well. With that being said, I'll see you over on the next one.